Hello, 8th grade. Today we're going to review FOIL. This is a review from the previous weeks, and as I was correcting some of your work, I noticed some common errors, and I want to address those errors, and I want to give you some tips on things to remember so we can prevent making those errors when we're solving a FOIL problem. So the first problems I want to address are the problems from the lesson quiz. So we're going to kind of work backwards. We're going to start from the lesson quiz. Okay, so we're going to do some basics. Miss Hughes is going to be very repetitive today because I want to make sure I'm addressing everything because I saw a mixture of common errors. Okay, so FOIL. This is our method. And this is the algorithm that we use when we're multiplying binomials. Okay, so remember, binomials are problems that have two terms, okay, in each expression. Okay, so FOIL. So FOIL is first, stands for first. O is the outer or outside. I is the inner. And L is the last. And we're going to do examples that's going to show that algorithm. So first, we're going to do one of the problems from the lesson quiz. So we have x plus 9 and x minus 9. Now, when we are doing the FOIL method, or solving with the FOIL method, we're multiplying, okay? And it usually is in the form of parentheses because remember, parentheses means multiplication. So when we are multiplying binomials, and this is one binomial because it has two terms. It has an x and a 9, and an x and a 9. So both of these expressions are binomials because they both have two terms. Now remember, a term is separated by an operational symbol. Here we have an addition and here we have a subtraction. So we're going to do the first step to solving this FOIL problem. So the first thing we do is we're going to do the F, which is the first, and we're going to multiply the first two terms in each expression, okay, in each parentheses. So this is the first term in this binomial, this is the first term in this binomial. So we have x times x. Now remember, when we're multiplying variables, I'm going to write this on the side, we have x times x. There's an imaginary 1 here. It has an exponent of 1. And we don't, and it's invisible. We don't write the 1 because we already know it's 1, okay, by seeing that 1x. However, when we multiply variables, we are adding, okay, adding the exponent or adding the value. So x times x is going to give you 2x, okay? Not 2x as far as this 2x, but x to the second, okay? Okay, so let me erase that and we'll come back to that. All right, so x times x gives you x to the second, okay? And now we're going to do the O part, okay? So the O comes next, the outer or the outside terms. And when we draw the lines, what I noticed with some of the problems, we have all the lines at the top. So remember, you can use the bottom. It makes the problem a little less messy, and sometimes we can get confused. And I think I noticed that on a few of the problems. So let's do the outer now. Okay, and so outer means the outer terms of each of the binomials. So now we have x times 9. Okay, now not only do we have 9, but we have negative 9. So you have to remember, anytime you're taking a term, you are taking the entire part, meaning that the sign that is in front of the number as well. Okay, So whenever you have an operational symbol, it goes with the number that is behind it. Because remember, with algebra, you have to group it together. So we have x times a negative 9. So I'm going to write this over here. X times a negative 9. That's the next step. And remember, when we're multiplying opposite signs, so now we have to remember our integer rules. When we're multiplying opposite signs, it's a negative. Because this is a plus. We don't have to write a plus, but that's a positive. When you're multiplying a positive and a negative, you get a negative. So that's going to give you negative 9. Okay? So that's our next term. So now we're going to do the I. Okay? We're going to do the I part. Okay? And now it's the inner. So now I'm going to draw the line at the top of the problem. We're back to the top. And now we're going to multiply the two inner terms of the binomials, which is positive 9 and x. So we have 9 times x. And whenever you are multiplying a number and a variable, you just put it together. So it makes it easy. Okay? Another way to look at it, technically, there's an imaginary 1 here. Anytime you have a variable, there's actually an imaginary 1, but in algebra you do not have to write it. Okay? So always remember that rule. So I try to remember that each time. Okay? So we have 9 times 1 gives you 9. And then you just write the x. Okay? So now we're going to go to the outer, the last term. Now we're on the last, hello 8th grade. Today we're going to review FOIL. After reviewing some of your work last week, our lesson quiz and the problems that I gave you 21 through 34, I noticed some common errors, and I wanted to make sure that I review those with you so we don't make those mistakes in the future. Okay? So for this first problem, Ms. Hughes is going to do a very detailed review problem. And I'm going to review a lot of basics. Things that, I say throughout the year, but I just want to give a little refresher and a reminder to help us remember. Okay? Okay, so let's talk about the FOIL method. So the FOIL method is used when we're multiplying binomials. And binomials are terms, are expressions that have two terms. Okay? I'm going to write that in a minute. But when we're multiplying binomials, we use this algorithm called FOIL. Okay? And it's kind of like an acronym. So the F is for first, the O is for outside, or sometimes you will see outer. The I is for inner, and the L is for last. So let's try our first problem. So we're going to solve the problem x plus 9 times x minus 9. So these are two binomials, meaning that each expression has two terms. Okay? And remember, a term is always separated by an operational symbol. So here, there's an addition symbol, and here there's a subtraction symbol. Okay? So now we're going to go through the steps of the algorithm. So the first thing we do, we're going to, let me grab my color pens. We are going to do the first step, and we're going to underline the F, and we're going to process the first letter. The F stands for first. So we're going to multiply the first two terms of each expression. Okay? So that will be x times x. Because remember, anytime you're multiplying something within the parentheses, parentheses represents multiplication. Okay? So just a little reminder. So now on the side, here I'm going to show the work. Now you don't have to show the side work, but I just want to give you a visual representation of what we're doing. So x times x. So we're going to multiply x times x. Okay? So now that we're going to multiply those two terms. Remember, when you're multiplying variables, you are adding the exponents. Now these don't have exponents, but there's always an imaginary. Whenever you hear me say imaginary, what did we say? Right, imaginary 1. There's always an imaginary 1 here, but it's not written because we know visually that 1x is 1x. Okay? So now that we're multiplying these two x, remember I said we add the exponents. So there's an imaginary 1 and 1. 1 plus 1 gives you 2. Okay? So this first term is going to give you x to the second. I'm going to underline that. So also use your colors as we're going through this problem. So later on, you'll have all the side notes and what you should be thinking mentally and so on. So it can help you with correcting any past or future work. Okay? Alright, so now we're going to move on to the next step. So now our second step is our O. Okay? So I'm going to use this light green for our O. And we're going to multiply the outer. So now we are multiplying 9 times x. Okay? Now, one thing I want you to notice here, this is a positive x, but we don't never have to write the plus in front of the x. This is a positive x times a negative 9. Because as a reminder, remember, you always take the sign that is in front of the term. It goes with it. So when you're thinking about algebra, it's not really plus and minus, it's really negative and positive. So that is the way we are thinking. We have to kind of switch our thought, okay? All right, so now that we have x times a negative 9, and I'm going to write that on the side here, x times a negative 9, that is going to give you a negative 9x, okay? So one more thing I want to add. Not only is there an imaginary 1 exponent, but it's an imaginary 1 here. So now we want to multiply the terms again. But this is an imaginary 1. So this is just another way to think of it. So 9 times 1 is 9. Okay, so remember it's negative. And then we just add the x. Okay? So, little review. You can put this imaginary 1 here, or you really don't have to. It's just kind of like a natural algebra memory thing that we have to remember. But I just wanted to remind us of that feature. Okay, so now we're going to move on to the I. And what does that stand for? The I is for inner, right? So now we're going to use the blue for the inner. Okay? So now we have a positive 9 times the x. And remember that rule. So I'm going to write this one. So we have a 9 times the x. Okay? Now both of those are positive, so we don't have to worry about it. We just put them together, which will give you a positive 9x. Okay? So you saw the first gave us a negative 9, and then the next one gave us a positive 9. So let me underline, actually, with the same color. Okay, there we go. So now we're up to that step. So I want to bring something else to your attention. When we're multiplying, if you notice the x came first here, x times 9, but this is 9 times x. We always write the number in front of the variable. Okay? So that is always the standard way of writing it. Okay, so now what is next? What do we do now? Correct. Now it's the last. Now we are going, let's see, what color am I going to use? I'm going to use orange. So now we're going to do the last. And now we're going to multiply the two last. So now you notice that I didn't draw all of my lines on the top or on the bottom. So I switched it back and forth. So it's a clean problem. Okay, so now we have a positive 9 times a negative 9. So let me write this over here. Now we have a positive 9 times a negative 9. So a positive times a negative, when we are multiplying integers, a positive times a negative gives you what? A negative. Okay? So now we're going to have a negative 81. Okay? So what I saw on the work, the common mistake I saw was we were adding right here, because all through the problem we were multiplying integers. When we were multiplying integers, we were multiplying variables. So it kind of kept you in check as far as remembering what to do. However, when we got to this part and we just dealt with numbers, I saw 18. So you have to remember you're multiplying, and this last term you have to make sure that you remember to multiply all the way through. Okay, so now that we're done, we are going to simplify, because we're looking at this problem and sometimes some of us stop right here, but remember, we have to ask ourselves, is there anything else that we can combine? Is there anything that we can, any like terms that we have? So yes, we do have two like terms. And let's go over like terms. A like term is defined if the variable, the amount of variables is the same. So both of these terms have x's and they have the same amount of x. Okay? So you cannot combine this with that because this has two x's. This is x to the second. This, each one has one x. Okay? So these two terms are like terms. Okay? Now, here is where we combine like terms. Now, we have to go back, way back to our original combining, when we're combining integers. We're combining integers, when the integers are different, we subtract. Okay? When the integers are the same, we add. And what I'm saying is, this is a positive integer, this is a negative, this is a negative integer, this is a positive integer. Okay? So, they are different. So that means we subtract. So for this term, we're just going to bring it down. X to the second. So here, we're going to subtract. Okay? So when you subtract a 9 from a 9, it cancels out. Okay? So now you have nothing there. And now, you just bring back down this last term. And it's a negative 81. Okay? So, this is what you're left with. This is your final answer. Okay? Now, there's a lot going on here, so we're not going to do this for every problem, but I just wanted to address some things. Okay? And a little reminders. Okay? So, let's move on to our next problem. So, we're going to move a little bit faster. Now, since Ms. Hughes recorded this, you can stop at any time and take notes or rewind and go over what Miss Hughes said. So pause, rewind, you're able to do all of that. Okay? Alright, so let's move on to the next problem. Let's see which one I'm going to do. I'm going to do from our lesson quiz. Let's see. Let's jump around. Okay, this is number 3 from our lesson quiz. So now we have x plus 7 to the second power. Okay. Now, since you notice that the exponent is on the outside of the parentheses. So that means everything, this rule, this is our rule number, goes for everything inside. And it doesn't go for it individually. It goes for it as a group. Because remember, parentheses is also a grouping symbol. Okay? It means multiplication, but it's a grouping symbol as well. So let's write an example here. If I have in parentheses, 5 in parentheses, to the second power on the outside. This is saying that 5 times 5. We have to take the entire thing and multiply it by itself 2 times. Right? So if we have here to the third, and I'm just using this example, we have 5 times 5 times 5. Okay? So now that's with a number, numerically. So let's go back. And the rule applies. It's the same. So x plus 7, times x plus 7. So we have to write the entire thing twice. It's being multiplied by itself. Okay? So now I'm not going to use a color this time. I'm just going to use a black pen. So we take the first. Okay, we have the f. And remember, I said we add the exponents. So we have x to the second. So that's f. We have the outer. We have x times 7. So that gives us a positive 7x because both of them are positive. Then we have the inner, which will be 7 times x, which we get the same thing. And then we have the outer. So pay attention to this because I saw 14 at the end for this problem. We have a 7 times 7, which is going to give you a 49. Because remember, 7 times 7, 7 times 7, that's 7 plus 7. Okay, so now what do we ask ourselves right here? We ask ourselves, can we simplify? Okay, and simplify means make smaller. So remember that S. Can we condense this problem? Okay, so we have here, we have x to the second. And now our like terms. Let's look at our like terms. They happen to have the same number, and remember the way you do your check, they have the same amount of x value. Okay? So now we're going to have 7x plus 7x. Now this is when we do add. We have 14x, and then we just bring this plus 49 to the bottom. Okay? And that will be our final answer that you box. Okay? And that's that. Also, if there's anything if there's any questions that I'm not addressing, please make sure you email Ms. Hughes, or you can send me a private comment, okay, or question. All right, let's move on to our next problem. All right, we're going to do number let's do number 4 from our lesson quiz. This was interesting because especially to do this right after this problem. So with the first problem, we were dealing with positives. So now it's to the second power, but we're dealing with negatives. So we're going to see how this problem is slightly different. Okay? So now we have x. We're going to expand it. X minus 8 times x minus 8, because that's to the second. So now we're going to do our FOIL. We're going to do our f. Let's do it first. We have x to the second. Then we're going to do our outer. We have to pay attention here. This is x times negative 8. Okay? So that's going to give you a negative 8x. Okay? Then we're going to do our inner. Okay? And it's going to give you a negative 8 times x, which is going to give you a negative 8x. And then we're going to do our outer. And this is that multiplication of integers that we have to remember again. So we have a negative 8 times a negative 8. And remember, with the multiplication rule, if the signs are the same, it is positive. So a negative 8 and a negative 8 is going to give you a positive 64. Okay? So we're going to have a positive 64 at the end. And that was the part that kind of tricked us. So remember, write those rules, those addition and subtraction rules when you're the difference of combining an integer or multiplying a negative and a positive integer. Okay? Keep writing them on flashcards because that's the way you're going to remember. Okay? All right, so now, can we simplify? That is the question we're asking. So we have x to the second, and these are two like terms. Okay? So now we're combining. Let me write this x a little bit better. Sorry. We're combining. So when we're combining negative and positive integers, when the signs are the same, we add. Okay? Are those signs the same? Yes. Negative 8x and negative 8x will give you a negative 16x. Because remember, now why is it negative? Because you always take the sign of the highest number. Where there's really no highest number, because both of them are negative, so you know it's going to be negative. And then you bring this down plus 64. Okay? And that is the final answer. And remember, any additional questions, make sure you let me know. Alright. Let's see which problem we're going to do next. Okay, so let's add a little difficulty for our next problem. So we're going to do x plus 1, x to the second plus 3. Okay, so let's do our first. We have our f. Okay, now remember, there's an imaginary 1. So for this problem, I think I'm going to use a little color because it's slightly different. So remember, we add the exponents. So we have 1 plus 2 is going to give you 3. So now we have x to the third. So that's something new, because usually this term would have been x to the second with previous problems. So x to the third. Now we have our outer, and that's 3 times x. It's going to give you a positive 3x because both terms are positive. Okay. Then it's going to our inner. Okay. It's a 1 times an x to the second. So that is going to give you, it's positive, and it's going to give you x to the second. Now, remember with algebra, you never have to write the 1. But you can. If you wanted to write 1 x to the second, it is correct. However, in algebra, usually writing it properly, you don't have to write the 1. Okay? But we're going to write it in color for there so you can know that it's optional. Alright, so now we're going to do our last, and we have 1 times 3, and that's going to give us 3. Okay? So, now, what do you notice about this? What do you at this point, what are you supposed to ask yourself? Yes. Can I simplify? Well, let's look at this. Can you simplify this? No, you can't, because there's no term that has the same x value. Okay, so there's x to the third. So that means it's 3. That's 1x. This is x to the second. So you can't combine any of that. And this is a 3. This has no variables. So there's nothing you can combine in this problem. So this would be your final answer. Okay? Alright, so let's see which problem. Yes, let me go back to a similar simple problem. I'm going to show you a quick way now that we broke down. Okay, you may be thinking like, oh, we did this problem already. It's kind of different because the last problem we did was this. The symbols were the same. Okay, now I'm switching it up. Alright, So in algebra, whenever you have the two terms are the same in each parentheses, and the two terms are the same in the end of the parentheses, and the symbols are different, it has to be exactly that rule. Everything is the same in each parentheses, set of parentheses, is just that the operation symbols are different. This is called the difference of two squares. Okay? Now, in the beginning, I wanted us to get used to doing the FOIL method. However, whenever you see this type of problem, you can multiply the first two. Just do the F and the L part of the algorithm. So let's do that. Let me draw it out. The first and last. So all you have to do is multiply the first two. Oh, I'm sorry. I drew that wrong there. Multiply the first two. The first two in each parentheses, and the last problem term in each parentheses. So x times x is x to the second, and negative 8 times positive 8 is going to give you a negative 64. So you can jump straight to this step and skip the middle step when you are familiar between the difference of two squares. Now, let me explain why they name it the difference of two squares. Because this is x to the square, so this is x times x. And the difference, of course, in word form, a subtraction sign is described as the difference. And 64 is 8 times 8. So this is the difference of two squares. Okay? So that's where that term comes from. Okay? All right. So remember, the x has to be the same, the number has to be the same, but the signs are different. That's the only time it works. Now, if both of these signs were plus, that rule does not work. If both of the signs are negative, that does not work. Okay? They have to be opposite. Okay. Alrighty, let's see here. So, let's do this one problem. There was quite a few people that got this incorrect, so I want to make sure I review this problem. Okay, so we have 5x minus 6, and we have x plus 2. So I think that it threw everyone for a loop because it was a 5 here, because we usually don't have different, for one, the numbers are different in both, and it has a 5 here and doesn't have a number here. Okay, so we're going to do the first, and we have 5x times x. So I'm going to write that imaginary 1 here. That help to guide us, help us a little bit. So 5 times 1 is 5. And then we have x times x. Okay? Remember, you have to add those exponents. So this is all imaginary. You have to remember from previous work. X times x, so we add the exponents, x to the second. Okay, so that's our first. And our outer. And we have 5 times a positive, and they're both positive. 5 times 2. It's going to give you 10. And now we have 1x. There's no x right here. So we just write that 1x. And that's a plus. So now we have our inner. And we have a negative 6 times a 1x, positive 1x. So that rule, that's going to give you a negative 6. And then we just write the x. And now we have our last. And that's a negative 6 times a positive 2, which is going to give us a negative 12. Okay, so now what do we ask ourselves? Yes, can we combine? Okay, so ask yourself, can we combine? Yes, we can. Okay, so we have these two terms because they have the same x value. So now we're going to just write the 5x to the second. So now we're combining terms. Okay, so the rule for combining unlike terms is we subtract. They're unlike, so we subtract. We always take the sign of the highest value. And the highest value is 10. So we're going to take the plus sign. Subtract 10 minus 6 is 4. And don't forget the x. Okay. And then we have negative 12. Okay. And that is our final answer. Okay. So I think this covers most of the common mistakes I saw, errors. If you have any questions or you want me to do any additional problems, please let me know. But make sure that you correct your work with purple pen. Okay? So you may want to rewatch this video and rewind to whatever part that you need. But you can always keep this for reference in FOIL because you will be doing FOIL in high school. Okay? I'm giving you a little introduction on a junior high level to be so you're prepared. Because there are a lot of students that don't know FOIL when they get to high school. So you're going to have that little introduction to help you out. Okay? Okay, so that's it for now. And I'll see you on the next review video.